Good evening. I'm B.F. Graham, founder of the Princeton Propellers, and on behalf of the Princeton Area Alumni Association and Quadrangle Club, welcome to tonight's program on vertical urban farming, a technological solution to farming in the 21st century and beyond. And greetings to our guests in Abu Dhabi and Australia, where it is now the middle of the night and late morning, respectively, and a hearty hello to all points between. I am coming to you from our Battlefield Parkside Studios in Princeton, New Jersey, USA. And tonight's speaker, Paul P.G. Gauthier, Director R&D, New Products and Systems Innovations at Bowery Farming, is coming to us from a location across town near the Princeton University campus. At the conclusion of tonight's talk, our speaker will take questions which you may submit at any time during the program via the Zoom chat function at the bottom of your screen. And now it's time to introduce Paul, a native of Nantes, France, and a leading authority on vertical farming, the practice of growing crops in vertically stacked layers in controlled environment settings that optimize plant growth and soilless farming techniques. This exciting technology is on track to mitigate the effects of climate change, contribute to a more equitable food system, and ultimately outpace traditional agriculture in meeting world food demand. Paul earned BS and MS degrees in his hometown University of Nantes in 2004 and 2007 respectively, where he studied cell biology and physiology, followed by plant physiology and agricultural productivity. He next earned a PhD from the University of Paris Sud in 2010. This was followed by a move to Canberra, Australia, for a 2-year postdoctoral fellowship at the Australian National University's Research School of Biological Sciences. While there, he taught courses on plants and global climate change. And then, in 2012, he came to Princeton. Over the next 7 years, he was affiliated with the Department of Geological Sciences, first as a postdoc, then as an associate research scholar in plant physiology and environmental plant metabolism, and later as a lecturer. In 2017, he was additionally named a lecturer at the Princeton Environmental Institute, now renamed High Meadows. That same year, he established the Princeton Vertical Farming Project, which extended beyond growing to tackling the hard research questions and gathering data on what will be needed for vertical farming to expand. In 2018, an offshoot of this project was launched at Forbes College to continue operations at the time Paul left Princeton for the private sector. First, to found Kerr Farms LLC, and later to join Bowery Farming. Beyond his wide range of vertical farming businesses and research interests on Earth, Paul is also studying ways to grow plants in outer space, a likely future propeller topic. But tonight, he will focus on earthly farming. And with that, I will turn the floor over to Paul.
All right, thank you, BFG. Thank you so much for having me tonight. I'm really excited to be talking as a Princeton Propellers. There have been 2 years since I will say I haven't talked to Princetonian, and it's a great pleasure for me to be among them again and to be speaking about vertical farming in particular. You bring me back a little bit in time or when I was leading the Princeton Vertical Farming Project. So with that, I will start my presentation. Okay, all right. So vertical urban farming, a technological solution for farming in the 21st century and beyond. I'm really excited to talk about that. One of the pictures you could see is from Bowery Farming. But before I start my talk, I want to make a few disclaimers to make sure that we are aligned there. The first thing is most of the information presented tonight are not considered proprietary or could be claimed to be proprietary by any of my current or previous employer, as far as I know. The opinions shared in this presentation are those of myself, so that's my own opinion, and they don't reflect in any case the current or past strategies that any of my employer could have or any of their point of view. And finally, the information shared in this presentation are the results of academic research that I've done before moving to Bowery farming, and they don't, and none of the information are related, linked to Bowery in any way. It's mainly a broad aspect of vertical farming and not specific to Bowery. So that's something that I wanted to precise starting on. So let me start by explaining, even BFG did a very good job presenting vertical farming. I kind of wanted to start with a definition of what vertical farming is. So vertical farming is a method of farming, of course, that leverage technology to optimize space and resources in order to produce higher yield per square feet of land. In vertical farm, multi-layers of plant are arranged vertically indoors and supplied with artificial lighting. Vertical farm is also known as plant factory with artificial lighting, and that was defined in 2019 and a little bit before by the famous Japanese professor, Professor Kosai. So let's come back to something that we know. So if we look at a greenhouse, let's say this is a greenhouse. All right, in a greenhouse, we will we'll put plants in a horizontal way. So plant will be next to each other, and the main reason is because the light will come from the sun, penetrate inside the greenhouse, and so every single plant will have access to light homogeneously, I will say. So that's kind of what a greenhouse is. We are all familiar with it. In terms of vertical farm now, the light does not penetrate the building, and instead the plants are placed horizontally and vertically at the same time and over multiple layers on top of each other. Of course, since sunlight is not penetrating inside the building, we usually use artificial lighting to power every single and to place light on top of each of the plants inside the building. So that's kind of what vertical farm, and when I'm going to talk about vertical farm, I'm going to talk about that. There is different definitions, but I really want to make sure that vertical farming is not associated with greenhouse. It's really associated with indoor vertical farming with no sunlight penetrating the building. The origin of vertical farming is coming from my dear friend Dixon Despommier. And in his book in 2010, he published this amazing book called The Vertical Farm, Feeding the World in the 21st Century. So just this book announced a lot already in 2010. And a lot of the takeoff of vertical farms start after that. In this book, Dixon Despommier explained a lot of what he think will be the vertical farm of the future and the way of farming. But if we really come back to the history of what vertical farm is, it's actually Dixon Despommier just kind of invented the word vertical farming, but he didn't really invent vertical farming. His book explains some of the previous works that NASA did in the late 80s and up to the 2000s, when NASA operated the biomass production chamber at Kennedy Space Center. He operated on 4 different shelves. That was the first ever vertical farm created in the US. And they tested different crops like wheat and soybean and potato. And most of the research done in this area were led by Ray Wheeler, who is also a friend of mine, and I've been doing amazing work on vertical farming, still working on it in different aspects. He ended up, of course, sending a plant to space in the International Space Station, among other places. Most vertical farm use hydroponic system. As you could see in the picture on the top left, on the top right, you could see that there is potatoes, and next to that on the left, you will find wheat. All of that is powered by hydroponic. But hydroponic is not a new technology. We have been actually, humans have been doing hydroponic for ages. It's not something new. You could probably remember from the history book, the Hanging Garden of Babylon. What was that? Was the first sort of known or remembered by humans of hydroponic system. So hydroponic system is very well known. The Egyptians were using hydroponic system, and the Aztecs and the Chinese were also using hydroponic system on lakes, mainly to grow rice or to grow other things. So hydroponic is really not a new technology, and that's not what makes vertical farm unique. Now, what do we mean by hydroponic technologies? There is a range of different hydroponic technology, and I'm going to explain very briefly each of the different techniques because they are kind of important when we think of the technology for the future. The first one is called NFT, or nutrient film technique, and this technique use some channels where the water will just create a small film of water underneath the plants, where the plants are going to get their nutrient and their water from. It's usually linked to a small tank of water, and then the water will recirculate all the time. So there's a lot of advantages. It's mainly used in greenhouses. You will find them everywhere. There is a lot of very well experienced companies that will install them in a greenhouse. Some of them have 40, 50 years of experience in the US. So it's really not a new technology, far from it. It also allows for the plant to have a high oxygenation, which is extremely important for the roots because, as you probably remember, roots are cells, and cells need oxygen to be able to respire like we do. And so it's extremely important to have a high oxygenation for the water. And the system, because it's a recirculating system, have a lot of water efficiency, very high water efficiency actually, because the water is always reused into the system and just adjusted. Some of the cons in this system are mainly the channels inclinations that could be complicated when you scale up, and also you will have the tubings tend to clog quite often as well. The next system is aeroponic, an aeroponic system. It's very well known because there is a company in New Jersey that use aeroponic. So it's very well known. The aeroponic is a very interesting system that can maintain humidity at the root level. We need water on the root, and then it will create droplets of water with nutrients that will stay on the root, and then plant will be able to access this nutrient to continue their growth. The main limitation of aeroponic systems is mainly the fact that the maintenance of the nozzle could be quite complicated, and we need a very efficient operation to be able to use it. The third system is aquaponic. Aquaponic, you may have heard of it. It uses fish, and basically the poop of the fish is used to feed the plant, and then the plant will grow with it. There is a lot of advantage to it because you create plant and fish at the same time, and if you get the right plants, then you have almost a meal already done. The main limitation of all of that is the fact that you need to know fish and plants at the same time, and none of them, people are specialists in each of these categories, and being a specialist in two categories at the same time could be quite complicated. Without mentioning that if you have an aquaponic system in your house, if you want to set up one, it may also smell fish quite a lot into your house. So that's kind of some of the limitation, but some companies are using that. And I know that the propellers have been talking about other kind of system like this before. The next system is drip system. It's also a very broadly used. You will find them a lot in strawberry systems where you have a tube that allow drip irrigation. You could put it in your garden. It's the same thing. We do it also in your garden. But the way with hydroponics, the way to do it is you could have your hydroponic system with drip irrigation, and then the water come back to the main tank, and then they recirculate. Recirculation is really one of the major advantage of hydroponic technology, and especially when you scale up. So there is a lot. The main, I would say, one of the limitations of this system is you will have to use a lot of tubing if you want to scale up. Just imagine one of the warehouse of Amazon full of hydroponic system. That's a lot of tubing to put just for drip irrigation. Then another technique is called ebb and flow. It's very similar to what we talked about some of the system before. The main aspect of it is it fills the water into the tank and then empty it. And so it will do that constantly. The reason for it is to allow for a high oxygenation of the root again. And sometimes, as you could imagine in the soil, like plants are not watered all the time. And so plants are actually used to have air space, air gaps, where they will find oxygen and also other kind of air. So having a lot of air into your system it could be advantageous for some cultivar or for some plants. The next one is deep water culture. Deep water culture is what I used a lot when I was at Princeton University. I use deep water culture because it's a bucket of water. You don't have a pump into it necessarily to move the water, and it's very easy to set up. You will find them also commercially available. You just can imagine it's a bucket of water with some holes where you put your plants, and they grow beautifully if you put an air stone into it, meaning you need to have, again, air into it, so then the plant like it. And it's very likely, and that's one of the limitations, if you don't put enough air circulation in your water, doesn't move enough, you could go into hypoxia, meaning the lack of oxygen, and it's not good for your plants. It's not good for us if we do in hypoxia. Definitely not good for plants. So that's the other comparison. Finally, the last system when we talk about vertical farm is the vertical system. Some companies have been using that and developing the entire business around it. It's interesting because the water can, using the gravity, just flow down, and it's pretty efficient in terms of vertical space usage. However, the limitation of it is the maintenance of the containers, the kind of the channels, the vertical channel could be quite complicated and also challenging. And also there is a limitation to how much vertical you could get to it. So you will probably need multiple flow to be able to use them on a big scale. So that's kind of the major introduction about what is a vertical farm and what system a vertical farm is using. Now, since I introduced and I talked about a lot of companies, let's talk about who are the major players into the categories. So it might be new to you or maybe not, but the ag tech, so agricultural technology landscape is actually quite broad. So if you look at this, there is a lot of different companies doing different things into the I would say into the landscape. And most of them on the top, you will see there is greenhouse grower and also sunlight grower. And so if I just focus on this will be what I call vertical farm, and indoor vertical mainly. And you will see there is a lot of players across the world. It's not just the US. You have some in Europe. You have some all over the world. 10 years ago, I would have given a totally different presentation with just a few players, maybe 5. And now we are more than 100 different players. Not all of them are in this quadrant. And Michael Rose, actually, we created this graph. Every year I have to update it, so that's why this one is 2021, because every year it's getting even more challenging to fit them into one page. So that's kind of what the landscape is, and I will go through some additional information there. And to give you an idea of how much vertical farm have been booming, I will say, over the past 2 years, here is just the investment of the top 10. I'm just talking about the top 10 investment over the past 24 months in vertical farm. It's already $1 billion, which is a significant amount of money for startups in a certain way. Most of these companies are still startups, and some of them are going public soon. But most of them, have received a significant amount of money, which also a confirmation that for the field that there is a future into it. And of course, not all these companies are in the same place. And I will say that I define the 4 steps of success this way. The step number 1 for most of these companies went through is a proof of concept. Proof of concept is something that 5 or 10 years ago, a lot of companies had to do to just even prove that vertical farm can work. Now I think we are past that. Everybody accepts that vertical farm could be part of the solution. And now you can move to the next one. The next step, of course, is step number 2, which is scalability. It's very easy to, like I did in my lab, to have a very small scale and run a vertical farm by myself. It's very easy to have it in your basement, and we think, oh yeah, I can make it very big. It would be very easy to do, but it's actually quite challenging to scale it up and to make it at a very big scale. And then the step number three, of course, is expansion. As soon as you have proven that you could do it at scale. Now it's a question to how many times can you replicate it? Can you grow it majorly? And then the final step, which is a very interesting one as well, is the innovation and the profitability kind of like step. What that means is we'll need to, at some point where the technology has been established, and that's why you see this, the reduction of the size of the triangle coming down. The technology at some point, you switch from a technology company in a certain way to a farming company. And that's kind of what these two triangle present here is like. Initially you start with a very high technology company where you need to invest in the infrastructure, you need to invest in the technology, and then the more you move on and the more your company grow and build up, you will end up to need more farming and more experience in growing plants, because of course diversity and a lot of different things are getting more and more important in the future because your technology is already proven. I'm not saying that you move out of technology. You will see there is still a small fraction of the triangle that will be inverted into it, but it's kind of like a shift that some company will have to do over time. But now I've presented vertical farm and I said, it's an assumption. Everybody thinks that vertical farm is there, but why vertical farming now? Why now? Why in 2021 we are talking about vertical farm? Why in 2010 Dixon Despremier was able to talk about vertical farm? Well, the first one is the world population is growing. It's something every year, every day, we add more people on this earth. And as you know, there is already 800 million people suffering of hunger across the world, and so we know that it's a major issue that we'll need to solve. So when we think about 2050, where we'll have 9 billion people on the planet, it's adding 2 billion people from where we are today. So it's a significant issue that we need to solve very quickly. And the growth also of many regions, the growth of the population is also happening in regions where the food is very scarce, like Africa or Asia, and the projection actually shows that Asia and Africa will be the main top continent with the highest population growth over the next 20 to 30 years. So it's a major problem because if they don't grow food, who's going to feed them? And so that's something that to take into account. The second challenge is the fact that the population is moving to the city. I usually say that farmers have been doing an amazing job with their kids. They've worked very hard to make sure they manage to put them into college. And as soon as the kids manage to get to college, they work for 4 years. And then the first thing, especially the millennials, they want to stay in the city. They want to have fun with their friends. They want to stay in the city as they don't come back to the farm where their parents made a living before. And so that's a major issue. And we know that cities are going to grow. That's number one, taking over some of the land also usually available for agriculture. And so there will be desertification of rural areas. And there will be more citizens and less farmers. So that's a major issue. One of the things that when I present to students at Princeton every year, I have this presentation for the first year. One of the things that I always ask, and I have like maybe 100 students in front of me, and the first thing that I ask is who part of this group, who want to be a farmer? And usually there is no hands that raise. And so that's a major issue. Of course, I know they are Princeton students, but if out of 100 people, not even one want to be a farmer, then who's going to feed these 100 people? And so that's a major issue. And then talking about students, we need to talk about the next generation that is on the rise. The first one is like, it's already passed. It's kind of my generation in a certain way. But there is a generation now that held a lot of assets, and they are the millennials. The millennials are asking for different kind of food. They are a different generation. They are concerned about their health, the origin of the produce, how they taste, etc., which is kind of a switch before in the society that it's quite interesting to look into. Actually, McKinsey and company did this amazing comparison. I really like this graph because they really show, if you look at the baby boomer of the Generation X, what was important as a consumer versus the generation Y and Z, which is millennials and generation Z, you could see that it's totally different. The generation Z, they want something like being part of the community. They want to, they will question a lot of things. They want to be very realistic about the thing. They don't, they really move into a different thing. They want something unique, unlimited, ethical, all this kind of thing. Even in their food, it's really impacting into their food. So that's kind of like how the switch is making. And that's bringing something which organic food have been on the rise also over the last 10 years. The demand for organic food has doubled in 10 years in the US. It's a significant amount of increase into the market. And the main reason is because the millennials want organic foods. They want, something better for their health, for their body, and they don't want to put things with a lot of pesticide, a lot of hormones or anything. And they're really concerned about that. Problem: organic food produces less yield. And so if we want to feed the 9 billion people by 2050, if we only produce organic food, we'll have a problem, a major challenge of producing this food, because we know that in some cases, of course, here it's just staple crops, but it's true for everything. Organic produce usually yield lower than conventional farming. So that's a dilemma that we need to deal with. On top of that, there is an increase in food demand that will pressure current agriculture by 2050 by the fact that more people are going to get wealthier. So people are getting to get wealthier over time. And then more calorie per capita will be consumed. And if more calorie per capita will be consumed, that also means that we'll need to produce even more food by 2050. So that's a big challenge. We have a lot of all this issue coming up. And of course, I haven't talked about the elephant inside the room, which is climate change. And climate change coming to the game, I think I will say at the bad time in a certain way for us. Because when we look at some predictions that some publications have done, especially in the IPCC report, you could see that if we estimate an increase of 3 degrees by 2050, most of the regions of the world turn red, meaning that the yield are going to be 50% less to what we currently have. And so that's a major issue. Where are we going to grow our crops? And then you will see that you could see, for example, like if you look on this map, you see that some areas in Canada or Siberia or other places are getting green. The problem is you're still in the north, and so you have 24 hours of sunlight over the summer and no sunlight over the winter, which make your seasons extremely short. Talking about seasons, we have seen that over time, there is actually a shift of seasons. Our summer are getting longer and our winter are getting smaller. You will say, oh, maybe that's only could be a good thing for crops, right? Well, the issue is most of our crops have the evolution of the crops over time have actually evolved with this alternation, alternate seasons over time. And so by having shorter winter, something like strawberries, for example, need what we call a vernalisation. Vernalisation comes from hiver in French, so winter. And vernalisation is the time that a certain amount of hours, of days of cold that the strawberry plants need to be able to flower. And so if you reduce the winter, that some species may not have enough time. And then also longer summer could be a challenge for us, because that also means that longer summer, longer drought, less crops. So there is a lot of challenge just by this single observation of season shifting. On top of that, we have seen an increase of the frequency of extreme weather. We all know that sometime in the middle of winter, we'll have, I remember a few years ago, we had like 70 degrees on December 24. And it will be just a few days, but just a few days can mess up an entire season for the farmers. And that's a significant amount. Even like a very hot days, we have seen sometime in Princeton, I remember when I moved in, I remember someone telling me, oh, don't worry, like we just have 1 week over 100 degrees and then it come down. Well, I know that in the past few summers, we had more than that. So it's just a small example. And I also want to mention, like that's usually when I talk about climate change, that's something that I mention. I as a French, I always think of Peanut, like Charlie Brown. And what does Charlie Brown do over the winter? Well, he go to the lake and he skate. when I came to 7 years, I stayed at Princeton. I skated on the lake at Princeton just once. And that was really an experience. But I know that it used to be a big tradition for Princeton town and Princeton University to go skating on the lake over winter, and it's not happening anymore. So that's kind of how the change are making, and plants are not adapted to this kind of situation because it's moving very fast on top of the very cold time and very hot time sometimes. And this is reflected in the way US pays their farmers. So the US government, USDA, have been paying farmers for now a very long time. And just over the last 25 years, 424 billion, see, it's so big that I can't even pronounce it, $424 billion got paid to farmers to accommodate and to be able to compensate for some of the loss that they have. 8% of these subsidies mainly is due to what is invested into the disaster program. This disaster program is meant for storm, like unexpected storms that destroy culture. It could be drought, it could be fire, it could be flood. All of that, farmers can have a compensation from the government. And then the commodity program, which you see on the right, which is more than 50% of this price, is mainly due to the fact that when a farmer have something in stock and can't sell the crops that they have, then if there's a difference of price, like for example, over the past few years, we had a problem, like farmers were not able to sell their soybean because of they used to sell it to China, and so the government then pay to compensate for the difference of price. So all of that is coming in a certain way out of the taxpayer, and so that's something to take into account as well. Like weather and climate is really affecting the way we crop in the US. And unfortunately, I wish I had a better news, but well, I do actually, a little bit more slide, but the impact of climate on crop is actually quite significant. And so some projections that have been made here, you will see a decrease of 6% per degree Celsius. So per each degree of temperature that go up in the future, you will see a decrease of 6% of yield for wheat, maize and soybean, and also rice. So all these different aspects makes that weather or climate in general have a significant impact on crop for now and for the future. Well, you will say, well, one of the possibility will be, well, we just have to put more land. We just said that climate change is going to increase a little bit the temperature, so we may have more land available. Well, the problem is the amount of land available to grow plants is actually decreasing per capita significantly. There's not enough land on Earth to grow enough crop for the growing population. And so that leads us to one of the biggest example of what the Food and Agriculture Organization of the United Nations have presented in 2015, saying that we need to increase our production of food, the yield increase by 77%. Just keep this number just for a little bit, 77% higher than what we are already producing today. How is it even possible with everything that I just said before? It's just the challenge is so high. I mean, we a lot of people mention that, and we just say, well, we're going to do it. And yes, farmers have been doing an amazing job, like trying to get the better crop and to grow them in a more efficient way and in the field and this thing. They can do all the effort that they want. Unfortunately, if they have an extreme weather, if they have like a storm coming up, they can't plan for a storm. They can't plan for what is around the corner. And that's kind of the problems that we are facing right now, is because of the extreme events that are happening, and also the change of weather that could come one day to another and could affect your entire crop. It's a significant problem. So how now vertical farm help tackling this challenging? And I want to say here, I said help tackling. I'm not saying they're going to feed the world or anything. I'm just saying it help tackling these challenges. First of all, like vertical farm is locally grown. It's very well known in the US or in different parts of the world that there is food desert everywhere. And so the fact to grow them locally means that there is no transportation, which is also an interesting aspect, but also is grown where people are living, which is quite interesting. As an example, 97% of the fresh food in the US is actually coming from Southern California. So, you know, if you can grow them now locally next to New York, like Bowery Farming does, right outside the city, then you don't have the transportation. And then when you have something like COVID hit and the truck can't transit from the Southern California to the East Coast, well, it's always good to have a farm producing a lot of food right outside the city. In the same state in a certain way, or not very far. So that's help. Vertical farm also can produce 100 times more food on the same piece of land. The main reason is the same thing, we stack on top of each other. And because you stack on top of each other, then of course you will produce more food, right? If you just use the land that available on the ground, then you can't produce more. On top of that, and something extremely interesting, especially when you live in New Jersey or in New York, around the cities, most of these areas are actually not accessible to grow food at all, because we all remember the former industry. Some of them will, like, some of the soil will be spoiled with lead or for other chemical compound. You can't grow food into it. Well, the great thing is you build a building on top of it and then put a vertical farm there. It doesn't matter because you don't use the soil. So it's a really interesting aspect to it. We also save more. We can save more than 84% of water. One of my students, when I was in the Princeton Vertical Farming Project, Jasenia Haynes did a senior thesis and studying. I think actually she's 2018, but she did a senior thesis on vertical farming, and she compared. She finds some information about how much water was used to produce lettuce in the field, and she finds that we could save up or even more than 84% of the water. So it's pretty efficient when we know that there is not a lot of water around us. We could grow food and feed the urban areas where kids of farmers are not living. You know, I talk about the kids, like the farmer putting the kids to college, and then the kids were living in the city was great. Like, the great news is now that you have a farm next to the city, we could leverage the knowledge that they got, because when you grow up on the farm, you know a lot of things. And then we basically bring the farm to them instead of them going to the farm. So that's a very interesting part as well. We can grow food anywhere, independently of weather or climate. You could imagine, I mean, right now they're growing food in Antarctica. We could grow food in space. We could grow food in the Arctic, or you can grow food anywhere. Even, why not, in the deep sea? I don't know. We could just think of it like in the middle of the Rockies, in the mountain. You can grow food anywhere. And don't get me started. I'm going to go like crazy in different places. But that's really the potential of vertical farm. And the great thing about all of that is it's pesticide free. So we don't need pesticides. The main reason is because you build a building, you make sure that you have a pest management into it. So making sure that there's no pest coming into it. So you have the fresher food and the best food ever. Now, I presented you vertical farm, everything seems to be perfect. And why haven't we done that for a long time? And I will say, so what are the main challenges of vertical farm at this point? As part of my work, I identified a few challenges. First, there is like five major challenges that vertical farm face and need to address, and most of them are addressing it now. But the main thing is business. You need to have a good business model. You need to find where the business is. There is no reason to produce food if nobody's going to buy it. That's a major one. Biology is a very important one. As I said, crops are used to grow outside, and now suddenly you put them inside. They're not used to this environment, so it's extremely important to understand what kind of crop can grow inside, and also breed, meaning creating the plant or crossing the plant, selecting the plant that will grow better inside and indoor than outdoor. So that's another one. Sustainability is another challenge that vertical farm have to face, mainly because it's a new industry, and always as a new industry, there is a lot of sustainability questions that need to be addressed. And but as I said, we save more water, but there is some cost linked to energy, mainly light. But the great thing is you could make it way more efficient, and we can work on making it more efficient. This is just an engineering problem, and I'm just saying just, and it's like already huge, but it is something we can deal with. And then finally, labor. Labor is a very interesting one. As maybe some of you may know, but in farming, over the summer season, they actually bring people from South America or Central America to work in the field for a few months, and then they go back to their country. Vertical farm right now have not necessarily leveraged this aspect, and that's something interesting that they can do. But the main reason for it is because it's not seasonal. We grow all year long, and so then you don't bring people just for a season. You have to bring them in and keep them in the country in a certain way. So there is some challenges there. The other thing is vertical farm is quite complex in a certain way, and so we need qualified labor. There is different way to tackle that. You could make a system simpler, but that's kind of a different thing. And to tackle this issue, I created, when I was at Princeton, different programs with schools, local schools, to inspire the next generation of farmer and consumer. Because of course it's new, it's coming from inside. People are not used to this crop growing inside, and so what we should do. And so the Hopewell Elementary School is the first really program that I started while I was at Princeton. And then we also created something similar with Princeton Middle School. And then the Forbes College that BFG mentioned is something that we wanted the student to be familiarized with it, to just interact with it. And I know that the Hopewell Elementary School has been a very huge success for it. The kids go into the room and ask for greens. I mean, like, I'm not a parent, but I have heard that so many times, like how many kids ask for greens all the time, and they actually beg their teacher to please give them a wrap of lettuce before they leave the room, and they don't want to go back to the classroom. So it's really working, having the kids interacting with it. The problem with the school system is, you grow, especially in the East Coast, it's extremely difficult to have crop outside and to have the kids enjoying it, because by the time, sometimes we have very long winter. So, it's difficult to grow anything. And in the fall, you can't really grow anything. So it's difficult, but indoor, you could just use a classroom and have everything growing. And that's amazing. And the kids are in instruction with it. So that's how you inspire. And the kids of today are the consumer of tomorrow. So you can also create a business over there. So we kind of tackle with this kind of experiment, we could, of this kind of design and interaction, we could tackle different aspects there. The other program that I created while I was at Princeton University is something called the Princeton Environmental Ideathon. And as the main thing that I was thinking there is inspiring Princeton students to think about how could we create better cities for the future. And by just doing that, you tackle every single aspect of what was the challenge that vertical farming is facing. Because if you think of a city where you already integrate vertical farming into the system, where we could grow, let's say in the middle of Manhattan, just growing like, greens like it used to be in Central Park. So it's a possibility, and it's really great to see that we could do it in the building. There is a lot of innovation come with it. I remember someone once asking me, why would you teach vertical farm to kids? And my answer to them was, why would you teach rocket science to kids? Not all of them are going to launch rockets. Well, not all of them are going to grow food, but at least it keeps them thinking at the beginning, and who more than kids have time to think. So that's a great thing. When they get into college, they have a lot of ideas, they can develop them, and they can get going very fast, like they will do with rocket science. And so that's kind of like the analogy that I always make. Now, I talk a lot about technology and things. So what are the technological opportunities for vertical farm? But let's start with, I will say, our main actor here, the plant. I've talked about technology for the past 30 minutes, but I haven't talked at all about plants. And plants are really at the center of vertical farm. Plants need CO2, water, nutrient, light, and all different kinds of nutrients. That's how they behave, that's how they grow. Balancing resources, all these resources for plants, is key for maximizing their growth. And if you put too much sun, then you damage the plant. If you put too much nutrient, you damage the plant. So plants are really in balance, and everything interact with each other, and everything is important to be able to control. Now, if you modify one parameter, you lead to an adjustment of all the others. That's what we call the law of the minima. There is always one limiting factor, and being able to control everything at every single stage will maximize the yield and the productivity. And the power of vertical farm is you could actually do it. You could manipulate everything. You don't have to care if you are going to have a cloud in front of the sun for like the next 5 hours. You actually provide. I mean, if you want to create one, you can. But you have all the power of controlling that in a very precise and a very accurate way. And so maintaining optimal conditions, it's at every stage. Sometimes we think that, of course, agriculture and farming have been in a certain way. You put some nutrients, they will grow depending on the stage, it doesn't matter. In hydroponic, it actually makes sense, but it also gives us a capacity to change. Like, for example, a seed doesn't require the same thing that a seedling. A baby plant is not going to require the same thing that a seedlings. And the same thing, a mature plant is not going to require the same thing. So every stage require a very different conditions and resources that could be easily manipulated inside a vertical farm. Now, the technology for the field is quite limited, actually. We could put robots into a greenhouse, or we could put robots into the field. People have been doing it. But the main limitation is there is one parameter you can't control. You can't control the sun. And you can also can't control necessarily atmospheric pressure. And so I remember, like, when I was doing my postdoc in Australia, I was working in a greenhouse, and I can tell you Australia have a lot of sunlight. But one of the things that I remember, I was doing measurement of the leaf. I was measuring gas exchange, so the photosynthesis aspect. And every time it was cloudy, I was saying that my plant were depressed. The same way we are when it's cloudy and not a beautiful sunshine. It's kind of like the plant were not as active as they used to be when there's beautiful sunlight. The main reason is they were different of atmospheric pressure and they were sensing it. They were not as active. So in the field, you have this variability, and actually, you will have a cloud that's coming, and so you will have less light. So all this variability makes the field less efficient than if you have a constant light and a constant conditions. But to be able to do that, we need to create automation for indoor farming. What I mean by that is most of initially when vertical farm got created, there were an effort of trying to translate all the technology from greenhouses to indoor. Unfortunately, because greenhouses is flat and greenhouses have not necessarily all the requirements and the technologies that we have into a vertical farm, it's quite challenging to just translate whatever is inside a greenhouse to a vertical farm. So when you stack everything on top of each other, if you have a small leak on the top level, it's going to go down to the level below. So it's a different technology. You also have cables, and you also have a lot of electrical power, you have lights, and so you don't want your water to get into the light. So all this kind of technology need to be adapted, especially for indoor vertical farm. And some companies have been doing it beautifully, and that's some of the examples that I give there. And there is a lot of movement into it, as you saw initially when I saw the landscapes. There is a lot of companies that are currently working on it, and it's really not a translation from greenhouse to indoor. It's like, okay, how can we make it work indoor? The potential for indoor has been presented in this paper. It's a very nice paper that I'm going actually to describe a little bit after that. So we did some work in my lab at Princeton, and you could see that the potential is amazing. None of these numbers have actually been verified. So it's kind of theoretical that they put in this paper, but just to think about like, if you look at spinach, the factor of increase is like 820 times. It's a lot of increase. I'm not even sure as they did all these calculations, but the fact that you could stack things on top of each other and you could grow in the same area of space, it really make everything growing much better. And so this paper actually suggested that we could feed a population by using a skyscraper farm. So they designed this entire skyscraper with every different level of a different crop growing. And they said that with this, you will use 3.5 gigawatts per year, gigawatt hour per year, and it will be 37 floor. There will be different things. You will occupy 1,936 meters square of ground. But it's a skyscraper, so it's $230 million to build, so it's quite significant. But you could feed 15,000 people for 2,000 kilocalories per daily. So, which is interesting, right? If you think of it. So I got one of my students, Alison Gloshinger, 2019 this time, did a senior thesis in architecture on it, and one of the thing of her work, she analyzed everything and think of like, okay, how can we power it? So one of the things that we talk about, we say, okay, how much power? You know, I know nuclear power is not necessarily the solution, but that was just an example of it because it's a small land area. And so if we talk Palo Alto, which is one of the latest vertical farm latest nuclear plant in Arizona in the US. You could power 9,240 skyscraper farm just with one nuclear plant, which is quite amazing if you think of it. And then that will occupy, and just by 9,240 skyscraper will feed a third of the US population. And so now if you put all of that together, all right, if you put all of that together, it will be just 1/3 of Manhattan. Just 1/3 of the island of Manhattan will be covered with skyscraper, right? And that will feed 1/3 of the population, meaning that if you fill the entire island of Manhattan with just skyscraper, okay, there is some limitation to it. You need to street in between, but let's just say that just for the concept, you could feed the entire population of US just from this area. So the power of it is really high. Now, again, this is purely theoretical. Will it be proven? Probably not. The cost of it is insane. If you think of it, like I was looking at it, it's just $2,000 billion. It's just crazy as a number. Just if you think of $230 million for a skyscraper. So all these projections are crazy, but you know that's something that we need to think about because there is a lot of technology. How could we make it work? And so then you come to my next subject, which is we have talked about a lot of things, but what about staple crops? And that led me to one of the research that we have made, and mainly driven by a comment that Dixon Despommier made to me at a conference. And he said, oh, you know, I believe that wheat and staple crop will never grow indoor. It doesn't make any sense. That's what a lot of my professors told me. And then Dixon Despommier looked at me and said, what if? And this what if got everything started. I put a team of experts together. We got some of them, I think, attending the meeting, but like we got like architects, engineers, plant modelers, and all of that together. And the main reason why are we talking about wheat? Well, first of all, wheat is the hardest one to grow. That's one of the, because it's pretty cheap to buy. But what we have observed is that the global cereal production, while it has been increasing sometime, the production is lower than the utilization. It happened in 2019. It happened also in 2011 and 2013. So we know that it happened already in human lives that we produced less than what we actually needed. And for wheat, that was also something significant. And if you think of it, actually, in some countries that import wheat, there was a significant amount of civil unrest and riot during a time where the price were actually pretty low. So pretty high, sorry, because they couldn't afford it. So that's a significant impact. Now, if we look at who import wheat, and I know some people will say, what, US is red there? Yes, US import wheat every year. And the main reason is seasonality. The main reason why US is not self-sufficient is because, yeah, we grow wheat over the summer, but what do we do over the winter? We sell most of the wheat, and then what happened? And so that's kind of like most country interact and buy wheat back and forth. So that's a significant amount. Then if you think of like increasing the slow increase of wheat yield in the field is actually quite slow. If you look at it from the 60s to now, it almost increased by 2 tons per hectare, which is not a lot. It's very small. So, and the main reason again, it's weather, it's better farming, better practices, but still it's quite slow. Some areas of interest, of course, is the Middle East and North Africa, and Africa in general. Some of these countries have been seeing like an increase of production of wheat. They have some amazing yield. You could see here we are talking about 10 tons per hectare, which is way higher than what we have. But the amount of land that they can produce is very, very small. They can't produce that, and it's also difficult to produce it on a regular basis and constantly. So there is some difficulties there, and you could see that most of the yields they get it from what they call the improved package, which I guess in this paper means GMO. And finally, as I said before, there is a high volatility of the price of wheat. We have seen in 2009, that the price of wheat went very, very high. and that lead to a significant amount of civil unrest in the Middle East and in North Africa. So so that's kind of yeah, that's kind of it about wheat. Now, so that's all the different challenges. As I said, we need to increase the production of wheat. That's what we said before. We had only a few countries that can produce, and it's extremely susceptible to climate variability. High volatility creates social and political instability, and that's a very big problem. And yield remain low while space is limited. So we asked the question, can we grow wheat indoor? Why not? I mean, you know, NASA did it in the biomass chamber, so why not? And so we had this paper that we have done the study, we run everything, and indoor farming could produce indoor 5 harvests per year. Usually a farmer will have just 1 harvest per year, and not more, eventually 2 sometime when you have winter wheat, but not more than that. Well, indoor we don't care about the weather. We could accelerate the ways wheat grow, and we could even do like 5 different yields, and we simulate that using a crop model. We could also optimize the growth to enhance the yield. And what that means is, right now, we use a paper by Monnier and Bugbee that was studying wheat for NASA to put in the International Space Station. And the World Guinness record outside was 17 tons. So we know that 17 tons per hectare per year is possible. It was done, I think, once in New Zealand, as a farmer. I've been repeating it again. And compared to Monnier, that was just 14 tons. And now if you put CO2, you put higher light, you put everything, you switch from 14 to 39 tons per hectare. So you triple the amount of wheat you can produce by just putting it indoor. Now let's model it. We have 1 floor, 10 layers of wheat. We could have a yield per year of 1,940 tons, which means that we are going more or less to feed 100,000 people with that. If you just think that it's 1/3 of the global utilization, and you won't necessarily need a lot of employees for that. You could run the facilities. The paper really like take into account every single categories. The main issue that we have is the cost of driving this facility. It's mainly driven by energy, and so energy, I always say, if it's an energy problem, let's talk about it and let's discuss, and let's make sure we could find a solution for it. And we projected to the future, saying that, well, yes, the energy is going to improve and we are going to get in a better place. And mainly when I talk about energy, as I'm talking about light, and light is part of this, is a significant amount of dollar per year invested into vertical farm for growing wheat, just for growing wheat. And so the technology, again, is where everything starts. If you think of improving technology and energy use efficiency, we could eventually decrease the cost return ratio by 2050. By 2050, we should be able, if we put enough brain together, to work into it. And remember what I said before when I talk about the subsidies. A lot of the subsidies that even US or the rest of the world are using are mainly going for crop insurance. They're not going for actually growing crops. Now, if we take some of this money and invest it to help the farmers or a vertical farm, like to grow wheat, to pay for the energy or to account for it, then it could help. And the energy can also come from solar panel and other thing. Now I talk about 1 floor, so let's go crazy. Let's go about 10 floor. We grow into, we scale up, we go to 10th floor, and now we can feed 1 million people just with 1 farm, which is quite amazing. Of course, it requires a lot of power. You could see here the amount of gigawatts that it will require, but energy aside, some people may need that. And in the Middle East, it could be quite significant. Now, as soon as we publish this paper on wheat, and I will finish almost on that. As soon as we publish our paper on wheat, I had a lot of questions. And one of them is, is vertical farm going to replace conventional agriculture? And I will tell you no, it's never meant to be. It has never been meant to be, and it will never be meant to be. Remember, we had to increase by 77% the yield of what we are already producing now. So we better partner with the farmers and add on top of that vertical farm to be able to feed. And just the example that I'm giving here is we did this analysis when we said, okay, if we replace the entire production of wheat from Nebraska, all right, we could see that the amount of space required for growing is very small. The indoor wheat cultivation will be very small, only 24 kilometers square. But the amount of solar panels that you will need, it's exactly the same amount, or almost the same amount of space that right now you are growing wheat. So why would you do it? So that's kind of the aspect of it. It's never meant to replace it. It's just meant to supplement it, and that's really supplementing farming. So vertical farming offer tremendous opportunity to tackle some of the biggest challenges that mankind is facing regarding food supply. It's massive. Vertical farm is not the solution. And what I mean by the only solution to feeding the world. And it's part of a range of solutions that need to be developed in order to achieve our goals. The technological innovation and advancement are major lever for success of vertical farming. What I mean is there is no way vertical farming is going to be to be useful unless we innovate and we create a technology. A lot of people are already doing it. I'm not saying it's not possible. We are already doing it, and I will say we are already doing it. And then plant physiology is the next level for producing even more and acquire a deep understanding of plant growth, and to be able to tweak the environment and to manipulate to make the plant as optimal as possible. And vertical farming has flourished over the past 10 years and will continue to bloom to become part of a sustainable food production system. And everything can grow indoor. And I literally mean everything can grow indoor. The question is, should we grow everything indoor, and how much it's going to cost? And as soon as we say how much it's going to cost, it's a technology question. And so that's kind of like the possibility of vertical farm, in my opinion, are countless. So that's kind of where we are. With that, thank you so much for your attention. Back to you, BFG.
Thank you, Paul. I learned a lot. We will now turn to the Q&A portion of our program. And this is a good time to remind those of you who may have tuned in late that your participation confirms your consent to be recorded and appear in all online publications and rebroadcasts of this propeller. So the first question we have is from Bill Lull, and a regular propeller attendee. And his question relates to the nutrient film technique, which was one of the first ones you mentioned. He wants to know, why doesn't a filter solve the pipe clogging problem?
I will say the main reason for it is as soon as you have water and you have a lot of things growing, you will also have algae, and that's kind of why you bring an entire ecosystem as soon as you put a seed into the system. So that's where the filter can help, but not going to solve everything. But yes, that's one of the solutions that could definitely be used. But we have seen, especially in my farm, I know that at Princeton Vertical Farming, we had a lot of issue with algae that were growing into the system and clogging the pipe. So that's part of the things that we have to deal with.
Our next question comes from John Rigonati, another regular propeller attendee. And he asks, the ongoing pandemic seems to have halted the movement of world population to cities, at least for now. Do you think this is going to continue, or is it a temporary change? And what do you see and when that influences vertical farming?
Well, I think, so first of all, the pandemic has been a very positive aspect for vertical farming in many, many ways, because vertical farming provides protected produce, meaning that nobody have really touched the food before. And during the pandemic, it was extremely important for people to have safe food that they can eat and make sure that nobody touched it before. That's number one. Number two, I think, yes, people are going to go back to the city. Of course, we have seen something amazing that we are doing this talk on this presentation on Zoom now. Everybody have been using Zoom, and a lot of people fled out of the cities. But usually if you fled out of the city, that means that you're going to create another city somewhere else. And so the demand is going still to be there regardless. And in the future, especially the millennials, they want to be in the cities. They want to go to a bar. They want to go to they want to have fun with their friends. They want to be together, and that's kind of like, that's not going to change. And that's kind of what will drive this dynamic towards the city. Continue driving that in the future.
Okay, Paul, our next question, actually, it's a couple of questions, are from Stephanie Thomas, actually a previous Propeller speaker, and she is the Vice President of Princeton Satellite Systems and a dual MIT alum. She works in the area of fusion, and she comments that this sounds like a good application for fusion, and she has two questions. Let's take them one at a time. The first one is, how many harvests per year can you get for a plant like strawberries that require cold in the cycle?
Well, I will say a few more that you could get into the field. It depends which plant you use. There is different kind of plants. Some of them require a significant amount of cold, but if you think of it, it's just a way to think of how do you rotate the number of crop you have in your system to make sure that eventually they get a cold area. You could put them into eventually a cold room, put them back into the system afterward. So it's a question to think about how to use technology in the system to allow them to do that. But and some strawberries are able to produce all year long. So that's more than the field for sure.
And her second question is, how about things that grow on trees, nuts and avocados? What are you doing with respect to vertical farming for those crops?
I haven't heard anybody working on it, but one of my students at Princeton had a small project of creating we were working on a coffee tree, and she got this coffee tree from seeds and started to grow it. Unfortunately, she got very busy with her semester, and the coffee tree died eventually. But it's totally possible. Hydroponic can grow anything. Now, considering nuts and everything, I think the main challenge there is the number of years is going to take before you get your first harvest. I think it's an investment right from the beginning, but if you have to supply energy to be able to get this artificial lighting to your plants, it's a significant of money spent into energy without any return on investment until you finally produce it. So I think the main reason why people haven't been moving in trees is because it takes way too long to grow. However, there is a very interesting research from USDA, and his name is Chris Dardick, and they have been doing, and also Ray Wheeler work with them. And some of the work that they've been doing while creating dwarf plum trees and dwarf apple trees, and they manipulate and they manage to get the tree to produce plum almost after 1 year, so very quickly. And it's a very small tree, so the distance also allows them eventually to put them into a vertical farm. So there is a lot of innovations that have to come into this area, and I think I don't see why not. And we could imagine a multiple floor with a lot of artificial lighting just supplied to trees, but it's a different challenge. I will say everything is a new challenge, which I think is exciting.
The next question relates to something in the political realm. I heard this past winter that New Jersey Senator Cory Booker was named to the U.S. Senate Committee on Agriculture, Nutrition, and Forestry, where he chairs its subcommittee on food and nutrition, specialty crops, organics, and research. In this capacity, have you had any interaction with him or his staff? And if so, could you describe it? And if not, do you plan to?
So the political aspect is not my role inside the company. So inside Bowery, I'm not at all involved into it. While I was at Princeton before, it was definitely not part of this commission. I think it's an interesting point of view. It's an interesting aspect. I definitely in the past worked with USDA to define urban farming and define a program for urban farming and vertical farm. So I know that there is a high interest from the government and to move into this direction, but I have not necessarily interacted directly with him or never plan to do so unless unless I'm asked to do so.
Well, maybe that will happen down the road. The next question is, this one comes back down to individual citizens. What could you suggest for individuals in terms of creating vertical farming units inside their own homes, albeit at a vastly smaller scale than you were doing at Bowery Farming? For example, what equipment and growing media would they need to acquire, and where could they obtain these items?
I think there is a lot of possibilities there. I show the deep water. I think is the easiest one you could get. Again, it's a bucket of water. A lot of people have been doing it. You could find a lot of do-it-yourself online on YouTube. They will explain to you what material to get. You could get pipe and put things into it to get an NFT system. So there is really a lot of possibility. It's quite easy to set up. You just need the water flowing into it. Then it also requires a lot of attention and a lot of care. So if you have enough time to do it, or if you have kids that can eventually, it could be their summer project or their project, I think it helps a lot. In-house, it's possible to do. It require, again, it come back to farming. It's going to come back to the same thing, which means that it require to be on schedule and to be able to know when to seed and when to harvest and so on. So there is a lot of possibilities there. You will need a bucket, some pipe, and yeah, that's kind of all what you need. There is not a lot. And then in terms of media, there is a lot of option out there. For what I created for Princeton Vertical Farming and also for Forbes College, everything come from Amazon. I bought everything online, and so it's extremely easy now to find everything you could online. It's very easy to get going very quickly.
Okay, and it looks like, oh, well, we have some more questions. Here's one from Greg Dobbs. Could you say more about CO2 enhancement possibilities? The NASA slide you showed had about 3 times the average atmospheric amount. That's his first question. And why don't you take that before I launch into the second one?
Yeah, so plant photosynthesis is a component of 2 things, light and CO2, and need water as well, but let's put water aside. So if you increase the concentration of CO2 inside around the leaves, the plants are actually going to capture it. That's all the thing about plants capturing CO2. And so we could maximize the accumulation of carbon into the plant by increasing the concentration of CO2. And it worked very well. In the International Space Station, for example, that's one of the examples that I gave. The reason why the concentration was so high, it's just because inside the International Space Station, you get to 3,000 ppm of CO2 very, very quickly. And so but for plants, it's actually pretty good because they grow a little bit faster if you give them also enough light. So there is some limitations there. Again, remember the law of the minima. If you give them a lot of CO2s, then you need to give them enough light to compensate for that. And if you compensate with enough light, then you also need to compensate with nutrients. And so everything goes together, everything goes up. And there is kind of a cap. I think there is a maximum they can really handle. Photosynthesis is led by an enzyme called ribisco, and so it's a major enzyme, and there is a certain concentration of CO2 that the enzyme can work, and so the concentration of enzyme will determine how much CO2 is actually accumulated and how fast. So that's kind of how we simulated. We started when we did the simulation. We found that around 2,000 ppm of CO2 inside the facility. If we go above that, first the plant productivity was decreasing because we had other issues into it. We need to provide more lights, and there were a lot of significant issues with it. So there is some limitation with CO2.
His second question is, would concentrating the food supply in a cluster of buildings around a power source be a food security risk? I think he means a food security vulnerability with respect to terrorism.
Yeah, I mean, it is. I think I don't necessarily have a very strong opinion about it. I think, yes, you're right. I think it's could be a risk if the plant explodes or anything. I think that's what he meant. But yeah, I don't know. Yeah, I guess so.
There's a limit to what we can worry about. And it looks like this is our last question, and it is, you are interested in growing food in outer space, and that subject might potentially be a future propeller topic. Could you elaborate on what aspects of that you would be discussing if we did a future propeller on that?
Yeah, I could eventually discuss that. So as you know, there is a lot of missions going to space in the next 10 to 20 years. We are going to the moon. We are going to Mars. That's for sure. We're going back to the moon. I would say we are going to Mars, and it take about a trip back and forth between Mars and the Earth take about 3 years. And if you just think of that, we can't send anyone in space without considering how could they produce their own food, because a lot of things can go wrong. But if they can produce their own food somewhere, it will be possible. So a lot of the interest that I have are for space producing food on Mars eventually, or on the moon. There's a lot of research that I've been doing that are still going on. There's a lot of activities around it. There's a lot of possibility. We could even think of having a station right outside a planet and producing food inside where it will feed the astronaut, going on the ground and building the next generation. We are going to space to stay, and that's something amazing. I think Jeff Bezos not very long ago just said that he's going to ride his own rocket to go to space. It's good to go up, but then if you have a beautiful restaurant with veggies and everything you could eat up there, you could stay even longer. So why not? And it's interesting. So and we also know, for example, there's a lot of the work of Ray Wheeler have been showing that astronauts enjoy taking care of the plants. I mean, we all do enjoy taking care of the plants. There is nothing more beautiful than growing a tomato and then, harvesting it and eating it. And the same thing for the astronaut. They do a lot of their work day to day. They have to take care of the International Space Station. And we have all seen these pictures on social media of like the astronaut eating a piece of salad and getting super excited because they got 2 leaf. And that's kind of what the intent is making sure that we can produce a significant amount of food in space to be able to put first more people into space and to be able to stay on the moon and then further going to Mars in the longer term. So that's kind of I hope to do one day at least.
Well, I hope so too. And Jeff Bezos of Amazon is not only a Princeton alum, but he was in Quadrangle Club when he was here. So I think it would make perfect sense for him to play a role in a future propeller on growing crops in outer space.
Yeah, why not? That could be an interesting propeller for sure.
Now that concludes the Q&A portion of tonight's talk. And a big propeller thank you to you, Paul, for this wonderful talk on technical innovations in vertical farming. We also thank our attendees, an ever-growing audience of entrepreneurs, navigators, and the curious. Until we meet again in September, you can reach us by emailing propellers@princetonaaa.org. We're now planning our 2021-2022 programs. So we encourage you to send us your ideas for topics and suggestions for speakers who, thanks to Zoom, can be anywhere in the world. And now, wherever you are in Asia, Oceania, Europe, Africa, or the Americas, it's time to bid farewell. Our next propeller flight is scheduled for Tuesday, September 14th, 2021, 7 p. Eastern US time. Please mark your calendars. Until we meet again, this is BF Graham on behalf of the Princeton Propellers signing off and wishing you high spirits and happy landings.